if the cause of something and the effects are somewhat separated, there's a lot of denial, and people just can't get to see the picture. Methane, which is in the seafloor, but the shallow seafloor, not the really deep seafloor, but these shelves like off Siberia and various other places, has got a lot of this methane and it's bubbling up. And so there's all kinds of scientists looking at all this methane. It's a huge amount of methane. I mean, people have been going to the Arctic and cutting a hole in the ice and then lighting a match to see, and you get like a conflagration coming right out because the methane gets trapped underneath the ice. But now when you start melting that ice and start releasing this methane in these underneath the seafloor, that's one thing. But the second thing is that you start melting the permafrost, that's another whole kettle of fish. What's happening in the Arctic is, because it's been frozen for so long, you've got all this methane that's been accumulating. You got anaerobic decomposition of organic matter underneath the seafloor and underneath and in the permafrost that's there. We haven't even begun to release the permafrost. They're talking about staggering amounts. They're measuring it in gigatons in terms of amount of methane that's going to be released. As of 2016, now this runaway temperature is just departed from this data here in 2016. That is like a tipping point where things get out of hand. And so all these scientists are looking at these curves, and this is just only one feedback loop. And there's a number of feedback loops. That's why all these dire predictions about what's going to happen is because these feedback. If you look at this temperature, you'd say, okay, well, it's not any different than it was last year. Or, you got these natural variations. But when you get these feedback loops, and stuff starts running away. We're right at 2016, where the curves are starting to depart now, which is very worrisome, because then what you happen is
go from linear to exponential.
Yeah, you're starting to go from a linear thing.
My last grandchild, who was just born, will only be 15 years old at that point, not even out of high school. I was able to live a full, happy life, and he would not have had a chance to live a life if this all comes to fruition. There's a lot of people in that, young people, they won't have a chance. So that's what worries me the most.
I did bring something that I think you need to think about, and this is the CO2 monitoring that's been going on since the late 50s on the Mauna Loa Observatory by Scripps Oceanographic. And this is the Keeling curve, and what this says is that things are continuing to get worse. And the pre-industrial CO2 concentration in the atmosphere was about 280 parts per million. And we are now at 406 as of yesterday, parts per million. And this is really what is driving the climate change, and many of the aspects that have already been discussed. I did the 15-year expansion of this on the back here. In recent years, the parts per million has been going up at about 1.5 to 2 parts per million based on the global emissions. But just in 2015, we actually switched over from that 1.5 to 2 parts per million per year to over 3 parts per million per year. And so what I've done, based on this model that is well established, I have extended this on an annual basis, where we are up to, by 2030, we're gonna be at 453 parts per million in the atmosphere. Now, why is this important? Well, we are already in the danger zone in terms of the climate. That was when we passed over 350 parts per million. We are well beyond that now, and there are climatologists who say that we're going to reach the tipping point by about, well, you can see it here. That's the tipping point. We will not be able to go back from that because what has been said already about methane in the environment, that is a very powerful but short-lived greenhouse gas. But carbon dioxide is basically forever. It does not dissipate for 1,000 years or more. So, whatever accumulation that we have is going to set the course for how the environment is going to go from here on out. And what is really scary about this is, and what we ought to be concerned about, in addition to the climatic effects, is what's going to happen with respect to our ability to produce food, because the widespread famines and the water issues that are going to result of this, basically a permanent change in the climate going forward, is going to be what is going to cause the starvation and the civil unrest and the chaos that's going to occur. In addition to your list of problems.
6 items.
The 6 items. Well, I'll add another one, because the other problem is that the oceans are having a heart attack. The global warming is now causing a decline in the amount of oxygen, ability of the oceans to hold oxygen, because it's like
Okay, as the temperature goes up, you can hold less oxygen.
hold
Right, and that's a fact.
Oh, yeah, but the seas rise because of warmer.
and the seas are rising, and then it's changing the stratification. So again, this is another one of the feedback loops, that some of these things we haven't even thought about before, and now they are emerging, and they're big problems. And so if the people in the are dependent upon fish and other aquatic life are hungry now and having difficulty now, it's going to even get worse. Again, these feedback loops are not a straight line like you see here. They're going to be geometric. They're exponential, and so things are going to happen fast, and I don't think we'll be able to adapt.
Who do you listen to? This is our problem. Who are you going to listen to? James Hansen probably knows more about this business of global warming or climate change than anybody else. And he's got the data to prove it. But when James Hansen wanted to bring a lot of this information to our attention, George W. Bush squashed it. Cannot have this sort of thing. So the science is negated to the point of not having any meaning at all. And that's suicidal behavior. David introduced us to a term here not too long ago about being past the tipping point. Too little, too late. In my experience and with my knowledge base, that's right on the money. Are there going to be a lot of people die? absolutely. But I don't think many of us are going to be around to see this mass death. But I've got some grandchildren who are in grade school. And I mean, they mean a lot to me. I love them dearly. And so am I going to be concerned about our behavior and our policies now that will affect their future? Yeah. I'm concerned a lot about it.
The time between an event and between the cause and what happens, and if there's a large amount of time in between, there's a lot of denial, and there's a lot of obfuscation, and I made the comment, and 2 weeks ago I said about standing out on a runway in Kirtland Air Force Base when planes were taken off to drop bombs off on Yucca Flats, and the U.S. government made the military stand, have their troops stand 1 mile from the bomb, upright position, hopefully with their back to the bomb, and every one of them saw all the bones in their body with an instantaneous X-ray. 95% of those people died of leukemia, those soldiers. But the problem is it didn't happen right now, and that's where all the denial comes in from. And I always talk about that when I talk to young people about, I pull a gun out of my pocket and I shoot you, you're dead, okay? And I'm up for capital 1 murder. The problem is I can feed you bad food for 30 years, you're still going to be dead, and they're not going to do a damn thing to me. And that's just the way it is, about a lot of these things. So there's a lot of denial because people don't want to accept the truth. What's that movie about, you can't handle the truth. And that is true.
With this thing linear going exponential, it's gonna happen, it'll come on you so fast you won't know what hit you. So whether
That's
it's
the
15
worry.
years or 18 years or 9 years or whatever.
Pick a number.
Yeah, pick a number.
Kevin?
If you go back 2 million years ago, the hominids, and we're a hominid upright walker, there were 4 of them. So they call that the big party in Africa, because instead of 1, there were 4. Well, all of them have gone extinct. Neanderthals went extinct, 20,000, 30,000 years ago.
30,000 years ago.
Yeah.
So there is extinction of the genus Homo, and there's a long track record. I wonder if you saw or heard the Radio Lab about how the dinosaurs went extinct. It happened, it sounded like in hours or days, because
The meteor hit.
the meteor hits and it throws all this glassy stuff out which goes around the Earth. The temperature of the atmosphere was over like 1,000 degrees. Well, it killed off anything that wasn't underwater. Crocodiles survived, and the mammals survived in the little, holes or whatever. So that's pretty quick. Well, what if Yosemite blows up? It's a supervolcano. These events are not within our historical memory, but they are within our geological knowledge base, that there are things that can happen quickly. So, the reason we first knew about this, to start thinking about carbon dioxide, was from astronomers. So if you go back to your old textbooks from the 1960s, they say, well, how come Venus is so hot up there? It's the same temperature as you're inside your oven when you set it on self-cleaning. Well, they figured it out. It's because of carbon dioxide. So they worked out all of the chemistry and the physics of this. Well, how long ago is that now? 40, 50 plus years ago. They understood how carbon dioxide can create this thermal trapping thing, and we've got a perfect example in Venus of how this all operates. So I don't think I don't know that it's in the next 15 years, but I could conceivably see how you could create a loop, just as you did to create the last ice age, that could happen in that case within 10 years. So it wasn't, inconceivable to me, based on what we know in geology, that this could happen quickly.